Welcome to another tutorial. In today's video, we will learn how to forecast using three famous methods. Simple exponential smoothing, Holt's method, also known as double exponential smoothing, and Holt-winters, also known as triple exponential smoothing. These methods are crucial for predicting future data based on historical trends. Let's dive in. The first method we will review is simple exponential smoothing. For this purpose, we have the sales of our product from January to December. Before we begin calculating the forecast, there are two important things to consider. This method is typically useful when there is no trend or seasonality in the data. Additionally, it is used to forecast the next period, but it doesn't work well for longer periods. In such cases, other methods like triple exponential smoothing are more suitable. So, how can we determine if there is a trend or seasonality in the sales data? It's easy. Let's select the sales data and the months, then go to the Insert tab and choose a 2D linear chart. Once the chart appears, click the plus sign and select Trend Line. As you can see in the chart, the trend is flat, represented by a horizontal line, and the data fluctuates up and down without any clear seasonality. This tells us that simple exponential smoothing might be a good method to use. Now let's explain how simple exponential smoothing works. This method essentially calculates the forecast for the next period based on the weight we assign to the previous sales data and the previous forecast. To put it simply, it uses a percentage represented by alpha. The higher the alpha, the more weight is given to the actual sales, and the less weight is given to the previous forecast. On the other hand, the lower the alpha, the more weight is given to the previous forecast and less to the actual sales. This is represented by the formula displayed in our worksheet. If alpha is 0.8 or 80%, then 20% will be assigned to the previous forecast. Let's calculate this manually, following the formula above. In cell D6, we will forecast using the naive method, which simply takes the exact value of our first actual sales, 92. To do this, type equals C5 in cell D6. Now let's forecast for March. In cell D7, type equals. Then the first parameter is alpha, which is located in cell C1. We will lock it by pressing F4. This percentage is then multiplied by the actual sales from the previous month, which is in cell C6 plus cell C2, which represents 1 minus alpha, multiplied by the previous forecast, which is 92. Don't forget to lock cell C2. There you have the first method. Now let's calculate the absolute error, which will always be positive. This error measures how far the forecast was from the true value, whether the forecast was too high or too low. In cell E6, type equals absolute value of C6 minus D6 and then drag the formula down. The error is simply the difference, so in the next column, type equals C6-D6. For the squared error, just select the error and square it by elevating it to 2, then drag the formula down. Now, in order to calculate the absolute percentage error, select the absolute error cell located in cell E6 and divided by the actual sales in cell C6 and multiply it by 100 and drag the formula down. Now we can calculate the mean absolute error, mean error, mean square error, and mean absolute percentage error. To do this, go to cell E19, type equals average open parentheses, select the range from E6 to E16 close parentheses, and press Enter. You can then drag the formula to the right to calculate the other indicators. Now you might be wondering, what would happen if we changed alpha? Would the error change? The answer is yes. That's why Excel provides another tool called Solver, which allows us to find the minimum error by determining the most optimal alpha value. To use Solver, click anywhere in the ribbon, right-click, and select Customize Ribbon. In the Add-ins section, select Excel Add-ins. Click Go. Then check both Analysis Toolpack and Solver add-on and press OK. Once installed, go to the Data tab, where you will see the Solver and the Data Analysis tools. We will use Solver in a moment. Select Solver, and the first parameter you need to enter is the value you want to minimize, which is the mean absolute error, cell E19. Next, we want to minimize this value, so select Minimize. The next step is to define the value that will change, which is alpha, cell C1. Then we add the constraint by clicking Add and setting the limits. Alpha must be between 0 and 1. So add the constraint, alpha less than or equal to 1, then alpha greater than or equal to 0, and click OK. Leave the other settings as they are and press Solve. It will ask if you want to keep the solution. Click OK. Before moving to the next step, Excel's data analysis tool provides a way to calculate simple exponential smoothing. Click on Data Analysis, select Exponential Smoothing, and press OK. In the input range, select the sales data. You can include the header, and check the labels in first row box. For the damping factor, keep in mind that this is not alpha, but rather 1 minus alpha. So if you enter 0.8, alpha will be 0.2. In the output range, select cell I5 and press OK. Now you have the forecast. Why is it called smoothing? Because the method essentially makes the forecast smoother. However, remember that if alpha is high, the forecast will be more reactive to previous periods and will not be as smooth. Also keep in mind that you need to be careful when minimizing alpha with MAE or any other indicator, because you could get a lagging forecast, which means that the forecast reacts too slowly to changes in actual data. This happens when the smoothing factor, alpha, in single exponential smoothing, SES, is too low, giving too much weight to past values and not enough to recent changes. Now, let's review our second method, double exponential smoothing. Unlike the previous approach, this method is used when data exhibits a trend but does not have seasonality. Just like last time, we can quickly verify this by inserting a line chart and adding a trend line. Looking at the graph, we can see that sales follow a positive trend. In this case, we don't just have alpha, which controls the smoothing of the level, but also beta, which determines how much weight is given to recent changes in the trend. The higher the beta, the more responsive the forecast will be to fluctuations. The lower the beta, the smoother and more stable the trend will be, though it may react more slowly to changes. This method involves two key formulas, one for updating the level and another for adjusting the trend. When combined, they provide the forecast for each period. Let's begin by setting the initial level, which is simply the first sales value in January. Next, we determine the initial trend, calculated as the difference between sales in the second period and the first period. This initial trend serves as a starting point, but after that, it will be updated using the trend smoothing formula. Now let's input the formulas step by step. In cell C8, type the smoothing factor alpha located in cell C1 and multiply it by the current period's sales in cell B8. Then add the product of 1 minus alpha from cell C2, multiplied by the sum of the previous level, 120, and the previous trend, 12. The formula should be structured as C1 multiplied by B8 plus C2 multiplied by the sum of C7 and D7. With the level now calculated, we can determine the trend. In cell D8, type equal and select the smoothing factor for the trend, beta, which is in cell C3. Multiply it by the difference between the current level, C8, and the previous level, C7. Then add the product of 1 minus beta from cell C4, multiplied by the previous trend. The formula should be C3 multiplied by C8 minus C7 plus C4 multiplied by D7. Make sure to lock the necessary cells before dragging the formulas down. Once the values are populated, simply add the level and trend together to obtain the final forecast for each period. The formula for this in cell E8 is C8 plus D8. To visualize the results, select both the actual sales and the forecasted values, and observe how the predictions align with the data. Additionally, for accuracy assessment, you may calculate the mean absolute error, MAE, or mean squared error, MSE, by comparing actual sales with forecasts. This helps determine how well the smoothing factors are capturing the trend. Since you already know how to calculate it, I will leave it to you for practice. Now let's move on to our final method, which is used when data exhibits both trend and seasonality, triple exponential smoothing. We have the sales data for a certain product covering the years 2023 and 2024. And this time, instead of manually applying formulas, we'll let Excel handle the calculations for us. To begin, select the entire table, then navigate to the Data tab and click on Forecast Sheet. Here you'll find several options to customize your forecast. The first setting determines how far ahead we want to project our data. I'll leave it as it is, which defaults to forecasting 12 months into the future. Another key setting is the confidence level, which is typically set at 95%. But what does that actually mean? A 95% confidence level means that if we were to generate multiple forecasts using different samples of data, about 95% of those forecasted intervals would contain the true future values. However, this does not mean that 95% of the time, the forecasted values will fall within the interval. Rather, it indicates the reliability of the forecasting method over multiple simulations. The remaining 5% represents the level of uncertainty, also known as the significance level. Alpha equals 0.05. This means there is a 5% chance that the actual future values may fall outside the predicted range, either above or below it. Essentially, the wider the confidence interval, the more uncertainty there is in the forecast. Next, let's allow Excel to detect the seasonality automatically. You can also choose to include Excel's statistical output, which provides additional insights into the model's parameters. Since we've already selected our data and the value range is correctly entered, we'll leave the rest of the options as they are. Once we confirm the settings, Excel generates a new worksheet containing the forecast data. This includes the forecasted values, as well as the lower and upper confidence bounds. Looking at the results, we can observe that the data reflects seasonality, with the highest sales occurring in December and the lowest in January. If we navigate to cell 26, we can see a formula. This is the forecast.ets function, which is the built-in function for triple exponential smoothing in Excel. While this function can be used manually, I find the forecast sheet tool much more practical, as it automates the process and provides visual insights. Additionally, by enabling the statistical output, we get alpha, beta, and gamma values. Alpha represents the smoothing factor for the level of the series. Beta controls the trend smoothing. Gamma determines the seasonality weight, allowing the model to adjust for recurring patterns in the data. Another advantage of using this method is that Excel automatically calculates error metrics such as MSE, mean squared error, SMAPE, symmetric mean absolute percentage error, MAE, mean absolute error, and RMSE, root mean squared error, eliminating the need for manual calculations. These metrics help evaluate the accuracy of the forecast and identify how well the model fits the data. There you have it, 3 different methods to forecast and refine your data. Each method serves a different purpose and is suited for different situations. In reality, these methods are far from perfect, but they provide a useful framework for making informed decisions. Keep in mind that forecasting is not just about numbers. Your results will always be influenced by external factors such as price changes, inflation, market trends, geopolitical events, and many others. Understanding these influences will help you interpret your forecasts more effectively and make better strategic decisions. With all these tools at our disposal, Excel makes triple exponential smoothing both efficient and insightful, providing a detailed forecast while handling the complex calculations for us. And that's it for this tutorial. If you found this video helpful, please give it a like and subscribe for more content. Your support really helps my small YouTube channel grow. See you next time.